Hello, I'm Nicolette. Thank you for joining in. I'm a zoologist. I've been writing since I was 17. I was brought up in Australia where one is often at nature's coalface. My new book was published as lockdown started, March the 30th, Wildlife Encounters, Southern Seas and Shores. It's the second Encounters book. The first, Wild Encounters, Try Not to Smile, published 2016. The title, there are some funny bits in it, as indeed in the other book, but the smiling refers to the only instruction I had for my first snorkel. Basically, if you smile, your mask and your snorkel fill with water. I smiled continually because I was so delighted at seeing all these things I'd only seen in textbooks. Neither book was initially intended. I was just doing what I love, seeking out animals, trying to understand them and their place in the big scheme of things. What is going on in the natural world, what I call the real world. But in observing animals, people and places, and keeping detailed natural history diaries, I soon saw human impact on the planet becoming more and more obvious and increasing. These were stories and situations that needed telling, and I felt compelled to do it. For this talk, I've gathered together some of my collections made over many years, which I used in writing and illustrating the two books, and some original drawings to share with you. There's a lot of them. At times this dining room table was going to get overcrowded. My husband, the impromptu, inexperienced but very diligent and good cameraman, will double up as stagehand. In between and during showing these things to you, I shall read a few excerpts from the books. Let's wander along a shore in Australia and hot tropical shores. These are molluscs, most familiar to all of us as the garden snail. They have prominent foot, as you know, because they seem to glide at enormous speed through the garden, looking for lettuces and tobacco plants. They have a head with antennae, since they are certainly going, they know which direction they're going in. All molluscs share those qualities of a big foot. This is a marine version of the garden snail, but I want to show you a particular group of molluscs, the bivalves. These are a fancy and very extreme contortion of the garden snail, in that they have no head. They are buried in the sand or the mud because they're filter feeders. They're not going to go anywhere, so they don't need a head and antennae. Usually, they have two shells, but usually one only manages to pick up one off the beach. These are some fairly exotic ones. This one is from Australia. This one you'll recognise as the green mussel that you can get in supermarkets, comes from New Zealand. And this is an outsize scallop, again bought with the meal inside it, ready to be served for a special celebration. Do notice these quite prominent lines that pattern each shell. They're concentric lines running around the shell. These are all shells from the north of Scotland. These are the more exotic clams, also bivalves, as you can see, and again the lines are quite noticeable around each shell. This is a drawing of the giant clam, and you can see how it's got its two shells partly open, and it's basically pumping water in and out through these two siphons, because that is how it's going to filter its food. But I'm now going to take you beachcombing much closer to home. This is a beach on a wide, shallow bay wide sand, lugworms, and all the things we're familiar with in the foreground. You will see in this drawing part of the beach looking out towards the sea. Now, where is this beach? It's in the very far north, in northeast Scotland. It's actually closer to Bergen than to London. You can see Dunnet Bay and Dunnet Head. To the north are the sprawling islands of Orkney, like grounded elongated clouds of blue-greys, receding to the horizon like layers of shadows. At the western end is the island of Hoy, with barely a sign of human presence, sharp stepped cliffs topped with reddish moorland and finalised abruptly by the sharp pinnacle of the Old Man of Hoy. Here and there, on some islands, there are reassuring homely patches of green and pale lemon fields. Across choppy swells and the white horses of wind-whisked waves, the mainland is crowned with the imposing flat-topped cliff of Dunnet Head, the most northerly tip of the British mainland, and the cold North Atlantic. Below is Dunnet Beach. It is an evocative and changeable sea space, under racing smears and wisps of clouds, strewn sparse by the strong winds. And here one can gather these amazing beachcombing finds. In the drawing, these are the actual shells of the drawing, some of them. I will start with the razor shells. These bivalves bore, dig and burrow their feet into the sand and mud. The elongated razor clam, razor shell or Chinaman's fingernails, goes for a high-speed dig involving distinct stages of shell opening, closing, hydraulically inflating the powerful long foot, deflating and squirting water, repeated cyclically. The razor clam stands vertical, just out of sight, with short inhaling and exhaling siphons exposed, whereas otter shells can live in much deeper mud or sand, need therefore immense siphons to match, extending 2 or 3 times the shell length. The shape of otter shells is accentuated by delicate concentric sculpted lines, showing periods of growth, similar to tree rings. In the Icelandic clam, these very obvious lines have become enormously significant in studying climate change. On a few occasions, Dunnet Beach was transformed into a wandering trail of these shells and little else. They followed a gentle wave line as far as the eye could see. Vikings and early hunter-gatherers possibly recognised the potential of these very thick and strong shell-spoon scoops, having eaten the muscular foot within. Dished deep enough to be useful as small bowls, we had collected them as useful containers for years, unaware we were reducing breathtakingly special objects to the mundane. Their other special aspect is they are incredibly hard. They create the shell using calcium from the sea, carbon, very significantly, and oxygen, making calcium carbonate. The young clam larva is taken by the currents as part of the plankton until it finally settles on the seabed and it converts into a second type of larva. Both have these hairy fringes by which they can directionally sort of swim a little bit. It quickly grows shells. Those are its first shells, which would be this part just here. It quickly grows shells and burrows ready for life of filtering plankton food drifting down from above. far northern waters are cold, and this particular bivalve then grows and ages slowly, very slowly. This species is called the tree of the sea. It claimed the world record for animal longevity when an individual was dredged from a depth of 80 metres, 262 feet, in northern Icelandic coastal waters in 2006. It was actually my brother-in-law, James Scourse, and his team who came upon it. Named Ming, the shell was aged at 507 years. It was a baby clam larva in 1499, which was, of course, the Ming dynasty. Before we go on, we'll just do a little bit of stage management. This shell here, the Icelandic clam there, was chosen from my collection of Icelandic clam dishes. It was investigated in optimism as it was particularly large. My brother-in-law was very hopeful, but it was in fact remarkably young. It was only 126 years old, born in the same year as my grandmother, and had obviously had a life of plenty in the fast lane. My brother-in-law calls it the James Hunt clam. In order to, I will go into this in a minute, in order to age it at 126, they cut the shell, you can see the lines there, and then they look at the inside of it there, and it's cut across the hinge, which was where it started growing. Cods, seals and wolffish eat the clams, as does man. They're commercially fished to the point of wiping out some populations. They're particularly fished in the Baltic Sea, and between the years 1970 and 1985, 40% of annual cod production was dependent on Icelandic clams. Ming, born in 1499, was fortunate in living in an area of few predators and minimal fishing. Now, my clam was 126, Ming 507. You might say, so what? The answer lies in how and what creates the lines. And it also explains how and why they're measured and studied. Most people are familiar with tree rings, and this is a classic specimen. The giant redwood, a slice of which is in the Natural History Museum in London. It was 1,300 years old when it was cut in 1893, I think it was. Now, the sea tree of the sea, the growth lines are reflecting much more than the tree growth lines, within today's technology, that is, of observing what's in there. They reflect sea temperature, surface sea temperature, salinity, food availability, turbidity, sea level pressure, and currents. These show in chemical changes recorded in each year's growth line, each one of these lines, which would be visible through there to the analyst. Seawater, of course, contains oxygen. There are chemical changes in oxygen which reflect evaporation of water from the sea, which creates rain, snow and ice. And there's also chemical changes which reflect melting of glacier ice and snow, also rain, going back into the sea. Both of these are related to climate, and this is reflected, these changes in oxygen are reflected in those growth rings. From these measurements and calculations, you can find the sea temperature at the time of each ring. Thus, Ming's shell encodes 507 years of ocean history. Slow-growing shells are detailed timelines, and they found in Ming's, desperately looking for the graph. Oops, sorry, here we are. Too much stuff. Here is Ming's timeline. Born in 1499, died in 2006. You can see that here the temperature, which is down here, drops quite a lot, and that is known as the Little Ice Age between those years. What was very interesting, that even something one-off event like a volcanic eruption, the biggest that's ever been recorded in human history, 1815, shows in Ming's growth rings, and it was so large and darkened the skies so much that there was a famine that went on for a year in northern Europe and, well, actually all of Europe and North America. The volcano was in Indonesia. Also, Ming's shells shows incredible detail for our own times. Between the mid-1940s and late 1980s, there was a change in agricultural practices and introduced salmon and mussel farms in Scotland. These affected nutrients entering the sea in the same way that you would have green scum in your garden pond. That's what happens when you have too many nutrients. And these in the sea changed microscopic plankton, all of which was reflected in Ming's shell. One's tempted to think of the quote, "Those who don't learn from history are doomed to repeat it." Summarising, I will read a quote from my brother-in-law. One fascinating aspect of this work is that we have been able to cross-date the patterns of growth increments from one shell to another, so constructing long chronologies that extend beyond the lifespan of an individual shell. We are now approaching 2,000 years in Icelandic waters and able to reconstruct very detailed pictures of what was going on. This clearly shows variability in the temperature of waters around Iceland. Relatively warm in the medieval period, very cold in the Little Ice Age between the 15th and 19th centuries, with a marked recent warming, very marked, since then. These are key data for assessing the impact of human-induced climate change on the oceans. Now, how have these shells managed to sort of make a long chronology going for 2,000 years? If you imagine the bands of growth are a bit like barcode. Okay, move this. So, if we start with that, I've just done a few lines to give you the barcode idea so that you can see how you can get cross-referencing. Now, one shell, you find another shell which takes you up a few more years. Then you find another shell which tells you what happened there, because one can relate how it is there. And then there is another shell. Hang on. I think that one isn't going to relate onto there. We have to wait till this shell's found. It must have been quite a job setting this up in the first place when they started this research, because they'd come in dribs and drabs. So here it's relating exactly. So that takes your scale down there. Now if one puts in this one can confirm these, and it takes the scale a bit further down there. Remember, we're talking decades and hundreds of years with these scales. And so, in the end, it can all be lined up, and you have a chronology of time. Now, these are time records of cold northern seas. They would be similar in the cold southern seas, which is where my brother-in-law has been doing research very recently on what's happening under glaciers melting in Antarctica. In southern seas, there are long-lived corals, long-lived as they live as a colony and they keep building. So they're going to even be older than Ming. And these